to sum things up. This is my first video ever and I'm so excited, but before we get into the lesson, I just want to do a quick little about me. Currently, I'm a high school junior taking AP Calc BC, and if you're watching this, you're either taking BC or AB, or you just really like Calc. But I'm going to be posting review sessions throughout the year on the topics that I learned in class to help myself review and to help you guys review, so hopefully we all get a 5 on the exam. And I hope that this feels more like a study session that you can tune into like once a week or whenever you feel confused about a topic, and not like a lecture, while still providing you with the information that I learned in class. So I hope everyone can benefit from this, and without further ado, here we have the introduction to limit. Okay, so the limit is the y value that the graph is approaching at a specific x value. So in this problem right here, at the x value of 2, the graph is approaching the y value of 1. That's what the limit is, and it happens to be that f of 2 is also equal to 1. So if we're using this specific problem here to fill out this, we'd have as x approaches 2, right here, f of x approaches 1. So then for this problem, we have same situation. The graph is also approaching 1, same limit, but f of 2, as we can see, there's a hole, it's undefined. Okay, again, same situation. What is it approaching? 1. What's the actual value? 3. Okay, so super simple, just a little get your head up to speed. So for this one, we're just going to do the limit ones. We don't have to do all these. But f of x approaches 1, f of x approaches -1. What's the actual value of 1 though? It's undefined. And then as f of x approaches 2, I shouldn't have drawn a dot actually there, ignore that. F of x approaches 2, and the actual value is 3. So, right there. Given interpretation, this is the same statement as it was above, so as x approaches 7, f of x approaches 10. Okay, that's all we really need to know for this beginning lesson because, guys, this is super simple. Okay, so the one thing I want to talk about on this worksheet is what happens when both the graph from the left and the graph from the right are not approaching the same value. So this can be seen right here, because this right here is approaching 4, and this right here is approaching 0. So what do? Boom, the limit does not exist. So my teacher said this, I'm going to tell you guys this. In Mean Girls, when, oh my gosh, what was her name? When she stood up, what did she say? The limit does not exist. So keep that in your heads, so when they are not connecting, when they don't go to the same value, the limit does not exist. Okay, guys, so solving a limit with tables, I'm not going to go over this too much because I feel like it's very self-explanatory, honestly, and also I don't have my calculator on me that much, so it's all going to be kind of like hypothetical numbers. But what you're going to want to do is you're going to put this equation into your calculator, and then you're going to have to change your table setup. If you've never done that before, you go second, table setup, and change your independent to ask. So that way when you go onto your table, you can input the x values yourself because we're going to have to go up to the decimals. So for making this table, you're going to want to have your x value that you're trying to find your limit for in the middle. You're going to want the value to the left because you want to see the values leading up to 1 and the values leading up to 1 on the right and left. So on the left, it's going to be less than 1. On the right, it's going to be a little bit greater than 1. You want to get very close. So it's going to be then 0.99, 0.999, 1.001, and 1.01. So you're going to get values. Since I don't have my calculator, let's just make this super hypothetical. So let's say you have 1.57, 1.78, 1.98. This is obviously leading up to 2. And then let's say on this side you have 3.65, 3.39, 3.10. That's leading up to 3. So going from the left to 1, it does not matter what 1 is, guys. Let's not even find it. And then going up to the right. So this little minus here means from the left. This little plus here means from the right. So From the left, we can clearly see it's going to 2. From the right, we can clearly see it's going to 3. If this was saying the limit with no from the left, from the right, would it exist? No, it would not. The limit does not exist because these two are not equal. So that's really all there is to it. If it's just, more complex fractions like this, it's just all your calculator can do it. So that's all we have to know for the table. It can come in handy if, you really are so confused and you don't know what to do. It's just a little time consuming to type all those numbers in and figure out which way it's going into the graph, but it works. Do what works. So algebraic properties of limits. This is also if you guys took AP Pre-Calc, you're just going to have a flashback because this is what we did for one of the topics. Don't ask me about AP Pre-Calc, guys. But really what we're going to do is just plug it in. Also, guys, I just want to do a disclaimer. I'm doing all this from the student perspective. There might be more mathematical reasoning. This is all we have to know. Let's not make it more confusing than it has to be. That's what I say. So just plug in. So it's always going to be going to around the same value. You know what I'm saying? They're not just going to give you a limit and you can't really solve it with the table, unless they do, but then you can notice it. So you just plug in. So the limit as x approaches. I realized a mistake I made while editing this, but I should not have rewritten the limit in this problem, because the moment you plug in for x, you stop rewriting the limit. And I talk about when to rewrite the limit later in the video, but I didn't mention when to not rewrite the limit, which is in this exact case. The moment you plug in that x value and solve for the limit, don't rewrite the limit, because it looks like you're looking for the limit of the math you're doing to solve the limit, when you should just be doing the math to solve the limit of a different function. So don't rewrite the limit, and I apologize. There's one. So this is interesting though, because if you're going to want to plug in the x for this x. So this would not be f of x of 1, f of 1. This would be f of -1, because it's being times by -1. So this is put in there to trick you guys. This is actually going to be 2 plus, what's g of x as it approaches 1? It's 6 over 2. We know that's 3. We know this is equal to 5. A little tip that I just figured out, which is not good because I was supposed to know this before, but when it's in the parentheses, so when this is in the parentheses here, that means it's the limit. That was what confused me about this before, is how do I know that it's the limit of g of x and not the point g of x? So that's because if it's in the parentheses. If it says something like limit as x approaches 1 of f of x plus g of x, and then it says plus f of x, this f of x is not the limit of f of x. That just means the point f of x. Because these are in the parentheses of the limit, that is, you're taking the limit of that. It's like redistributing the limit to all these things. This is not, it's separate, it's additive. So, a little known fact for you guys, because that's going to help. Okay, so we're just going to skip the other question, go to this one, because guys, we don't need to be fooling around with the funny stuff. So let's just plug this straight in. Well, actually, yeah. Okay, so this means if it's in the parentheses, guys, these are all being taken the limits of. So this is 5, as you can see right here. Right here, I mean. Okay, 5 times the limit of f of x as x approaches 5, which is 6, plus 2 times the limit of g of x as x approaches 5, which is -1, minus, if it's not in the parentheses, it's not the limit, it's the point h of 5, which is 3. So this is saying 5 times, 4 minus 3, okay, 20 minus 3, 17. That's our answer. I'm just going to go over B right here because I feel like it touches on the plugging in topic. So this is going to be, let's just rewrite it. So if you see x over 2 negative x, it might just be easier to rewrite it. So limit of x approaches 2. So f, what's 2 over 2? 1 over f of negative 2. So to plug it in. So now we just plug this in. We get, what's f of 1? The limit of this is 6. So 6 over the limit of f of x approaches negative 2. It's going to be negative 3. This altogether is equal to negative 2. Good. Okay, so now let's go to the graphs. So we have the limit. It's always easier to rewrite it. That's what I'm thinking. Oh, whoops. That's not 3, guys. X, that's 3. Okay. So as the limit of fx is x approaches 3. And remember, guys, this is not the point. So if this point was undefined, or if this point was like all the way up here and you plugged in 3, do not do that. It is the limit. So the limit is negative 1. So f of this is equal to negative 1. So we're plugging that in here. And then we find this limit again as x approaches negative 1. So we go negative 1 from here, negative 1 from here. The limit is 3. Boom. Now you guys know that. Algebraic properties of limits, done. Okay, this is the last limit topic that we're going to be talking about today. There's going to be another limit video because, guys, there's more on limits. Be a bigger fish to fry. Always remember that. So don't take too much time on the beginning stuff. Obviously, get your understanding of it. But we got to move fast. Okay, so now we're going to review limits algebraically. This is the last limit topic that we're going to be reviewing today, but there's more on limits. Obviously, there's a lot to do. So, the first part that we're going to go over is if there's, why is this so big? If there's no x in the limit, then you don't even have to plug it in. If it's just a number, it's just going to equal that number. The limit's always just going to equal that number. So if this was limit as x goes to, let's say, like 100, like of 10, the limit is always going to equal 10. If this was, it doesn't matter what this number is. If this was 8, it would still equal 10. Because think about it. A line that's just y equals 10, it's always the same value. It's always approaching the same value. Okay, so now let's go to this problem, number 6, before we jump into the other ones, because the other ones are way more tricky in my opinion. So we're just going to plug in, though. So if there's a x, just plug in for that value, and that's going to be the limit. So we have negative 2, 0, plus 1. Simple math, guys. It's equal to, why did I do a plus? Guys, this is what chemistry does to a person. 1. Simple, easy. Now we know the properties. So you just have to plug in. Algebraic. Let's skip to this one. So we're going to plug in negative 2 times 1 plus 4 is equal to negative square root of 6. Can you do anything with that? No. So that's your answer. So here we go into the hard part, guys. What happens when you can't solve it the first try? This is what happens. This is tricky. So when you see this type of problem, your first instinct, you want to plug in, right? So minus negative, or minus 3, minus 6 over negative 3 plus 3. Negative 3 squared is 9, minus 9, 0. We get 0 over 0. Mathematically, can this happen? No. Can we divide anything by 0? No. That's not right. We can't do this. So we just have to scrap this. We just can't do that. It does not work in math. And could I tell you why? Not fully. Do I have to know why? No. You just have to know you can't do 0 over 0. That's what I'm saying, guys. Let's not try to make it more complicated than it needs to be. I'm going to make this a little bit smaller. So what you're going to have to do is you're going to have to factor. What you have a 0 over 0, you're going to have to factor it out until you have something that cancels. As long as you have like one x that cancels, you should be good to plug in again. Try to like mentally plug in case like it doesn't work, so you don't have to like erase so much. But you just need something to cancel. And big thing is continuously write the limit while you're trying to factor it out. Like, don't just go boom, like factoring it out, like x minus plus 3, right? Like, don't just go straight into it. So you're gonna have to write the limit beforehand, and then when you plug in the actual x value, that's when you can ditch the limit, just plug it in, solve. So we still have to continue writing limit as x approaches -3. Okay, factor. We have x plus 3, x minus 2, over x plus 3. These cancel. Good. So now we can just plug in. So let's just like rewrite this, because you know how I feel about rewriting, guys. Always do it. Now you can plug in. So you have -3 minus 2 is equal to -5. Boom, boom, boom. You're done. That's all you have to do. Okay, let's do question 5 now. So always think in your head, can I plug this in, or is it going to be 0 over 0? You don't want to just go straight into factoring, because you could be saving yourself so much time. We know this is going to be 0 over 0 though. Like 2 minus 2, whatever the bottom's going to become 0 too. So we're going to have to rewrite the limit. Remember, always rewrite the limit as you're factoring. It's so important. X minus 2, x minus 3, x plus 2. Oh, guys, this is minus. It's minus 2. These cancel out, and we get limit as x approaches 2 of 1 over x minus 3. Now we know we can plug in. We canceled something out. So we have 1 over 2 minus 3, which is equal to -1. Boom, boom, boom. We're a pro. Okay, so today we went over what a limit is, how to find a limit from the left, how to find a limit from the right, using a table to find the limit, and algebraic properties of limits, and we touched on how to find those limits algebraically, especially with the 0 over 0 rule. And there's going to be more on limits coming soon, because these problems get so much harder, but it's good to have a basic understanding. So if anyone was struggling with what the limit is, or they just need a refresh, I hope this helped, and have a good day, guys.